right, class, today I want us to talk about whether or not we are choosing the correct distribution. So remember that we have two tables now. We have our Z table and we have our T table, okay? And there are certain times when we can use a Z table and other times we need to use a T table, okay? So if we know our sigma and our population is normal or our population is greater than 30, that's when we use a Z table. If I don't know my sigma and my population is normal but my standard deviation is 30, and my population is normal or bigger than 30, that's when we use a T table. Otherwise, there's nothing we can do. So let's practice going through this flow chart and looking at the next examples. All right, so I want to construct a 95% confidence interval. My population size is 23. My standard deviation is unknown, but the population appears to be normal. So we start. Do I know my sigma? No. Is my population normal? Yes. I'm going to use a T distribution. Okay, so see how I just went through this flow chart? Let's try that again. I'm going to construct a 99% confidence interval. My sample size is 25, my standard deviation is known, and the population appears to be normally distributed. So do I know my sigma? Yes. Is my population normal? Yes. That's when we're going to use a Z distribution. Now, I want to construct a 99% confidence interval. My sample size is 6, my standard deviation is unknown, and the population appears to be very skewed. That doesn't sound good. So let's go through our chart. My standard deviation is unknown. My population is not normal. My sample size is not greater than 30. So there's nothing we can do right now. We can't construct a confidence interval with this collection of data. So nothing right now. All right, I want to construct a 95% confidence interval. My standard sample size is 40, and my standard deviation is unknown, and my population appears to be skewed. So let's go through this. Do I know my standard deviation? No. Is my population normal? No. Is my standard deviation greater than 30? Well, yes, it is. So I'm going to use a T distribution. All right. I have a 90% confidence interval. My sample size is 100. My standard deviation is 15, and the population appears to be skewed. So let's go through our chart. Do I know my standard deviation? Yes, it's 15. Is my population normal? No. Is my sample size greater than 30? Yes, my sample size is 100. So I'm going to use a Z distribution. Next, my sample size is 9. My standard deviation is unknown, and the population appears to be very skewed. Okay? So when we don't know our standard deviation, we have a tiny sample size, and the population appears to be very skewed, there's going to be nothing we can do right now. If we went through our chart, no, nothing we could do. All right, I want to construct a 99% confidence interval. My sample size is 12. My standard deviation is unknown, and the population appears to be normal. So I don't know my standard deviation. My population is normal. I'm going to use a T distribution. Next, I have a 95% confidence interval that I want to construct. My sample size is 38. My standard deviation is unknown, and the population appears to be skewed. So I don't know my standard deviation. It's not normal. It finally got nice out, guys. All the motorcycles are out. And the sample size is greater than 30. So I'm going to use a T distribution.